All right. Hey, everyone. Welcome back to our 11th core R&D call. It's good to be back. We want to take this call to show you what we've been up to and what we have on the roadmap. Starting off with some logistics. If you're new here, some context. We're having these calls with core contributors every month. They're always recorded and uploaded to YouTube. So I do invite you to check our channel if you've missed the last ones or wanted some recap. I'll also paste in the chat and show notes a link to the Graphs ecosystem calendar, so you can be subscribed to future events like these ones and others such as community talks. Right. Okay. So with that out of the way, a quick tentative agenda for today. We'll start off talking about how we are with blockchain integrations. Then related to the above, we can talk about Ethereum Firehose. I know Edgenode has been working some testing with streaming fast, so we can talk about this. Along these lines, there's also new things that have been posted on the forum about bringing multi-chain support to the decentralized network. So that's a big one for sure. There's some interesting things over there. I think Adam can speak about this also with Ariel. And finally, we'll end up with something that might be of interest to indexers as well. That is Semiotic can walk us through their recent efforts on building an automated cost modeling framework that will be leveraged by Agora. So let me just accept people that are still joining the call. Okay. So yeah, let's get into the good stuff. It's been a while since we've talked about multi-chain, so I'll hand it off to Alex, Adam, Joseph. Maybe we can talk about Solana and Tendermint, how things are along. Could you guys speak about this for a little bit? Maybe you can start with Solana. Alex, you're unmute, so I'll pass it to you.
Well, yeah, work on Solana is continuing. So we've had the node running and producing, Firehose data for 1 month, which is really good. At some point, the nodes were less stable we had a harder time iterating on the boot process, like booting these nodes often takes half an hour. So we were trying to improve that. And at some point we decided, let's let it run and see if it's stable. So, the thing is stable for a month. We need to revise now the data model to make sure the data model is really robust. And things we've discovered even in ETH land, that we need to have total ordering within, how in a block in Ethereum, you have these logs, they have an ordering that is complete from the beginning of the block and the end, so you can have them ordered and know what happened. But the goal with the Firehose data is to have an extremely complete total ordering of events. When in Solana, there's beginning of instructions and end of instructions and changes to the state. We want to have sort of one counter to allow us to order everything, which gives us a clear picture of what happened during block execution. So we'll need to revise the data model for that. And then we'll need to make sure some other people are ready to run, consume produce those Firehose block and start serving Firehose. A lot of the work for, even integration within the graph node has been done already. We need to have the node running. So okay, that's my update on Solana. If there's questions, of course.
In terms of requirements, because obviously the requirements to run a Solana node are pretty meaty, like running a Firehose on top of that, like how's that looking? Is it something where you just need enormous amounts of sort of infrastructure, or have you got a sense of how difficult that's going to be?
Right. So normally, any node that is running master-to-master replications, writing. So in Solana, we're running a validator node, which is applying all transactions and all of that. Yeah, I have notifications on, but I can't mute them. So we'll see. Yeah, it is running, but oftentimes these nodes are already handling some sort of indexing. Either they're indexing in memory so that they can serve RPC calls, or the Solana node has a thing to write to Bigtable. So it's writing things to a database. There's a new account framework, account DB framework, that also writes to some other Postgres database or whatever. And these things take a hit on the node. But thankfully, I think with the Firehose, we can disable everything. We don't send anything to a remote server like, Bigtable, nor do we need to index anything in memory, because it's not the purpose of serving RPC queries. So we can shut down all the things that are indexing locally and just spew out the data. So there's not a lot of larger overhead than these other systems when the goal is just to spew it out and not even have the network round trip to a big table. So there's a small hit, right? There's a, I don't know about the number, like 10 to 20%, 5 to 15. I'm not sure exactly. We need to do some benchmarking optimizations for that. But it's not so bad. I think it could work, and it's done in parallel too. There's a lot of work that is done in each of these threads, so it's scaled with the number of CPUs too. So I think it's not so bad. Does that answer your question?
Yeah, I guess that's interesting in that. So you're not running a full, well, like a Solana node as you might otherwise. I don't know if you guys have thought of, because obviously when indexing Ethereum, you make like ETH calls like during indexing. Like, have you thought about whether that will be something that, I guess, do Solana, like, I actually don't know if a Solana nodes support those archival calls in the same way that like Ethereum supports archival calls, but yeah, is there a use case for that, or something, or do we need to think about
so
that?
Solana nodes do not do anything about archive in the same sense that you can't query past stuff. That data is just long gone when you query the node. It's really real time only. Well, a small something like that.
That could certainly be a constraint when you're indexing, I guess, and unless you're just fetching sort of state variables that don't change over time.
So I missed the beginning of the question, Adam.
I was just saying that's potentially quite a constraint to get around if, although I guess if everything's past as events, like I think the model's just different. I'm probably just thinking about it from an Ethereum perspective.
So in Solana, you'll not need, there's no read calls. You don't call the node to do stuff in the past or in the present. You get the data out and you're really querying the state, which you're not really doing in Solana and Ethereum. So Ethereum, you call a contract that interprets the data for you. In Solana, you query the data and you interpret it yourself. So once it's outputted in Firehose, you don't need to go back. Like Solana is one of these chains that when all the data is in a Firehose dump and you have that in flat files, then it's glorious because you have everything you'll ever want. The data is all there. And there's nothing that the Solana node would help you do more. So that's an advantage.
Got it. And when I guess because the Firehose is designed more for like streaming from top to bottom in terms of like interrogating that state, obviously it's in there, but like if you understand my question, like in terms of like something that is a bit like querying and how you'd support that when actually the main sort of Firehose interface is a streaming interface.
So, the way you query a Solana nodes is you ask for certain programs that are owned by certain things or that have certain bytes set to a certain value. And that you can do sort of something very similar on the Firehose data. The files are on there. You can match the beginning of the file, some values. And so we'll be able to do some querying of that sort. And like similar to what we have right now in Ethereum for address, for example, you'll be able to say, give me all the changes for program accounts that are owned by this program, something like that. And we'll be able to shrink it, use the same powerful stuff that Stefan wrote for Ethereum, for indexing. But I really think that, the streaming architecture, the stuff, substream code name thing will be the best way to consume that because we'll be able to reduce it. And there's a lot of data coming through to reduce it to some meaningful bits and bytes to consume downstream.
Cool.
Joseph, I don't know if you want to talk about Tendermint. That's some, I think Alex just brought up a topic we can talk about later on, but yeah, Joseph, you want to talk about Tendermint, how things are?
Yeah, sure. So I guess early this week on Monday or Tuesday, we merged all of our Tendermint PRs. That's great. It was peer-reviewed by Node and Streaming Fast, and now it's merged. That's great news. And just a little bit of explanation about what that means. is that in the Cosmos ecosystem, they call it Cosmos is like the internet of blockchain. So the vision there is that each blockchain is going to be application specific, where it's just built to focus on one type of applications. And in order for them to be able to achieve this vision, they created something called Tendermint, which is a package of the networking and the consensus layer. And then there's the Cosmos SDK to help people build their application layer, and it's very modern. So what we're doing here is that we integrated the Tendermint level, which is like the integration of those two layers. And now every time we want to add a new blockchain, we're going to go and add this application layer. And so what we're trying to do as well is we had some feedbacks and something interesting about the vision of how we could move forward with that, is that all these different chains in the Cosmos ecosystem, they are connected through IBC, and they can have their tokens transferred and their data. And so it's like really an ecosystem of different applications. And so the vision is that when the graph could start indexing these individual chain, we could become this kind of infrastructure where applications that need data from two or more multiple chains, they could be using the graph to collect all this data. And to achieve this, we had like a great idea with some customers. We're gonna try to have some kind of like a standardized schema across these different networks in the Cosmos ecosystem. So it could be really easy for people that are using two different subgraphs for two different chains to make something like this, almost the same call to get the same information. So let's say someone wants delegated rewards on Cosmos Hub, and they want delegated rewards on Terra. If you could provide this same standard schema across these chains, it could be easier for them to query it across chains. And so this is something that we are kind of focusing on. And next, we're going to be working on Cosmos Hub. We are pretty close to it. And next, after it, it's going to be the Terra chain in the Cosmos ecosystem.
So I guess at some point we'll have also, once we're ready to support these on the network, we might have indexers also using specific firehoses to those chains, right? So maybe we can start off. I know there's some, yeah, as mentioned before, we're working on Ethereum. I know, Adam, we've been testing some things with streaming fast. So can we also maybe share some updates there? I know indexers are trying to run Firehose for Ethereum, or at least I've heard from a few.
So I actually had a question just on the standardized schemas thing first. If that's okay.
Sure, absolutely.
Because I think this is. Hello.
Yeah, I'm getting people. Don't worry.
Yeah. So I think this is something really interesting. We talked about this the other day around like standardizing schemas, and like I think it could be maybe even broader than like just within, I guess, the Tendermint ecosystem. Because I don't know, like, is there a reason why you couldn't have a standardized schema that like across subgraphs in general, right? Like regardless of whether they're sort of Ethereum or like Tendermint, or like, is there something about the Tendermint ones in particular that you think is valuable, or is it just because that's a community already?
So that's a great point. Like, yeah, of course, we could also be considering how we could have like standardized schema across all different networks, even between Cosmos and Ethereum. And we like, for like when we got the idea and we got the feedbacks from some users, we said that we could start testing it in the Cosmos ecosystem and see how it goes. And yeah, sometimes like in the Cosmos ecosystem, some chains have the same kind of let's say specific calls that we can make, that we could assure that certain like percentage of the schema could be the same. But since every blockchain is for an application that is specific to this blockchain, they could have some different, like the schema would have something additional like on Terra than something on Cosmos Hub. So there are going to be some kind of fields that is going to be additional to one chain versus the other. But we were thinking about all that these fields that intersect from one chain to another, how could we make them standardized? So that's
right. I think because those chains all have the same consensus engine, the notion, for example, of a block, it's the same. And there's a spot there where you have chain-specific transactions and data. And in one chain that might be buy NFT, sell NFT, and another chain that will be, you know, transfer and withdraw, what's something like that. But there are a bunch of data structures that are similar. They're the same because of their commonality with Tendermint. And so the reward system and all these things comes at that base layer. That's why we want to have a common schema that is Tendermint-esque. And there's a spot for extension where you'll have those, you know, typed and richly typed types, but there's chain specific. So you have by NFT here, and they'll be in that same field. So we need to, it's the first time we have such a, let's say, a pattern in the protobuf definitions where we will have a large reuse of the base and some custom specific, chain specific things down low, right, in the transaction spot.
Yeah, and if I may add something as well, is that in the future, if we're looking at subgraph composability, where one subgraph could query two subgraphs, the idea was also, like we were talking with Masari, and Masari, they are interested in building their own subgraph for Cosmos Hub, but they are as well interested in collecting data from different chains. So let's say delegation rewards could be on Cosmos Hub on Terra. So if it is the same call, they could create, like, I don't know, like in the future or like just in the short term, it's the same call to get delegation rewards from Terra Hub and from Cosmos Hub. But let's say we integrated like more chains. Let's say we integrated now Osmosis and Stargaze. So Stargaze is like an NFT marketplace and Osmosis is the DEX. So if they want to query the price of a swap from, let's say, Osmo to Atom, it's not going to be anyway on Stargaze. It's only going to be on Osmosis. So we wouldn't need to have this standardized across Osmosis and Stargaze because it's a different code that doesn't exist there. Like the same thing as on Stargaze, you could be querying some kind of NFTs that is specific to Stargaze. But yeah, like there's going to be a big chunk of the schema that could be standardized across all these networks.
Nice. Yeah, I think I always think about the standards you see, well, the token standards on Ethereum, and I think we've said this for a while, but we need to have those kind of things, and they could go through like a GIP process. And Dave, who used to work for Edgenode, actually posted something kind of along those lines for lending. So I think definitely something we want to foster. But I guess, yeah, so then to get back onto the Firehose like Ethereum Firehose stuff. Yeah, so like Pedro said, we've been working on this for a while, and we've been updating this group and in our weekly meetings like on it for a while. I think let me just pull this thing up, and I might put some people on the spot. That's okay, but I guess here's a Firehose. I love this picture. I don't know. I feel like you should be being pushed backwards. But just talking about the Firehose, just wanted to talk about a couple of initiatives going on. So the first one is sort of the Ethereum Firehose stuff. This has been has gone through a lot of testing, but the point I think we're kind of at is that we obviously believe that the Firehose is, or we know the Firehose is great for individual subgraph indexing, but got some things around like firstly, like finalizing our sort of POI confidence. So running lots and lots of subgraphs, making sure that the proofs of indexing are like consistent if you're indexing with an RPC or with a Firehose. And a lot of kudos to Matt from Streaming Fast, who's done a lot of the sort of thinking around like, what if you like start with a Firehose and then go to an RPC and then you go back again. Obviously, there are a lot of edge cases there, particularly because the RPC like works in one way, keeping track of the chain head, and the Firehose like has another way. But obviously, the preferred course is that you can kind of mix and match between them, and there are no problems. If there are those kind of problems, then we'll need to think about introducing Firehose indexing in a different way, which might be sort of more version controlled. But obviously, the preferred case is that we can just sort of blanket switch over. And we're doing some testing at the moment. I think one thing I wanted to highlight, and I don't know if that was covered there, like this, people may know this, but to me, like the Firehose isn't just about like speed and faster indexing. I think there's a really cool space for, firstly, one thing here is more data being accessible in the mappings. When you're indexing Ethereum, you're kind of constrained by what you can get from the RPC, whereas like the Firehose like block can pass down like a lot more contextual data, a lot more performantly. So that's everything from getting receipts to like other things that are happening within a given transaction, stuff which we currently have to rely on, like trace filtering, which isn't supported by all Ethereum endpoints. So I just wanted to like highlight this thing. It's not just about speed, it's also about functionality. And like I think the one thing, Alex, which we talked about, and maybe you can describe, is this thing of maybe triggering not just on individual events, but on a sort of constellation of specific events.
Yeah. You want me to give a tat on that? Because
yeah,
I found it fascinating. I was studying, we were studying a lot of the pancake swap stuff. So Uniswap basically. And I noticed some usage patterns that were really, that made the code so crazily hard to read. And the code goes like this. One event, a mint event, for example, will have 4 logs. So if someone calls mint to mint some stuff in Uniswap, there's going to be 4 logs: transfer, and then a sync event, and then a mint event. It's really unfortunate that the mint event is last, because now you'll receive this one first. And because you don't have the context of the other things, you'll need to decide what to do with transfer. So what the code does now, it stores it in a temporary location called transaction. It's going to wait for the next one and then going to unpack what was in there already, and then try to say, oh, maybe this one, so these heuristics, maybe this one means a burn or a mint, I'm not sure. So I'm going to mark it as needs to be complete. And then I'm going to have a sync, just going to change the price, and then I'll get the mint. And now I can sort of back interpret what's behind. Oh, I forgot, that was not a burn, it was a mint. And the code really goes like that. Oh, this I was interpreting as burn, it's not a burn, it's a mint. Let's remove the burn. It's absurd. And the code is so horrendous. But, if we have, you should look at the code there. It's terrible. But there's a pattern here. Like, you can imagine identifying patterns like transfer, sync, mint. That's a pattern. Bring me the 4 together. And the thing is, there's important things in that transfer and that mint for the subgraph to work properly. We need those 2 things. But because you have them in a different order without the context, it makes it really hard, and the code is so horrible. But if we could pattern match, and sometimes, to make things work, this one is optional. Like, there's actually potentially 5 transfers, 2 are optional, you're not sure which one they are. So sometimes you'll have just transfer, sync, and mint. But that's another pattern you can match, right? You can say 3, 4, or 5, and those 2, and then you have them together. You can take better decisions, knowing that it's a mint series or a burn series, which are this burn is similar, just transfer, sync, burn, just to make it more complex. So yeah, having more data available, additional triggers, like we can see that with the Firehose can bring you that information all together, even though the node will not give you, when you get logs, contexts with these things, because we have scoped logs within one single call. We can know that these pattern match in one single EVM call, and we can pattern match on that. So is that what you meant, Adam?
That was perfect. Yeah. So I think there's a lot of cool stuff. And when you say the code is horrible, I think obviously subgraphs can be optimized, but this is also like a constraint of the current model where you just get event by event by event. And so you've got to create these tiny temporary states, which you then throw away. And I think David, I don't know if you know, he's on the call, has also been seeing some similar wrangling in other subgraphs. I'd say that this is definitely an area where having a different way of getting data rather than just getting one log at a time, I'm pretty excited by. The next thing I think then just on this was this sort of filter coffee. I don't know if we've talked about this, but I don't know if Stefan is on the call, but this is the essentially when we were doing a lot of the testing with the Firehose, we saw that the Firehose I think it cut its teeth on really dense subgraphs, so where there are lots and lots of events in almost every block. But then when you lined it up against a subgraph which was a bit more sparse, so maybe going for many blocks, basically smaller apps, then actually the Firehose wouldn't be as performant. And so I think this has been a piece of work which I think is generalizable that the Streamfast guys have done, which is kind of filtering down and essentially allowing the graph node to ask for a specific set of contracts or events. So, Stefan, don't know if you want to talk about how that works a little bit, if you're on.
Sorry, you want me to explain which part? I there's some noise here.
Yeah. I guess just the approach that you took, because I think when you've gone about it in a way that should hopefully generalize and be extendable, but basically the creation of these indexes on the Firehose side.
Yeah, basically we try to model a type of index that would allow matching what is defined in the subgraphs. So basically, what address, what type of method, signatures, and all of this. So we allowed we started by allowing in the request to the Firehose an array of protobuf any types so that it's flexible. We can add any type of request, and these we label them under the thing called transforms. So transform can define how I want my block transformed. For instance, it can filter out if I say I just want any call from this address or to this address for a method called transfer or something like this. It can shrink the payload of the block by skipping all the transaction traces that are not relevant to my filter. And if the Firehose can see that in the next blocks, in the next 200 blocks or 1,000 blocks, there's nothing that matches anything, it will simply jump to that next block. Because we have a, we send a cursor with each response, you may eventually get some blocks that are irrelevant, that have no content, but it still allows you to progress on your subgraph. This has been implemented on the Firehose for Ethereum chain and also for Near. So you can ask for Near block content by account, and you can also ask this filter. So you might receive just a block 10 and then 15 and then 2000. It really reduces the payload, but mostly the bandwidth for streaming empty blocks. When you get close to a live range ahead, the head, you will receive every block, but if you have the filter, they will be empty because there's no, you just so that you update your progress, block number, and block time, and all of this.
Yeah, awesome. Like, and I think that the fact that it's supported in Near is particularly salient right now. I think it's not. So I think Felipe's been doing some work on the graph node side to integrate the filters, and it's not set up for Near, but we've actually been having some degraded performance on Near this week. So can't wait for that because that'll make it go a lot faster.
I like to pitch just the feature that he's talking about there allowed us to shrink performance. You know, normally it needed to go through the chain and open all the files. That could take several minutes. And now for some large swath of the chain, because of that sort of indexing stuff, that are all files based, by the way, we can do that in 6 seconds, 5 seconds. It's much, much faster because you're not even opening files. That index tells you, don't open the next million blocks because you know beforehand nothing is in there. So the performance, like crazy. No, I didn't even think we could do something like that, being files based, but with some indexing stuff, and we're using roaring bitmap technology in there. Some of the things that they put low level in database systems, we're able to do crazy avoidance of loading data. So I think it's pretty cool.
Because all the data, the historical data doesn't change. We don't need any kind of stateful index. So we don't need, to have a running Redis or a running SQL instance to update the indexes and remove stuff. And so we can have those fixed length files. So the system will just look up for a file called 0 to 10 million. And in this file, it can look up a hash of an address or a type of query, and the roaring bitmap will tell it really quickly, well, there's some data around block 5 million, and then that's it. So we can skip all of this with a completely stateless system, just based on high throughput, high parallelizable distributed file system. So we're cutting costs of like operating in RAM indexes by having those really simple block boundary based indices on files.
Okay, I feel like we could spend hours always talking about Firehose stuff, right? It opens the door to a bunch of different things. But yeah, in the interest of time, let's try to follow along with the original agenda. Maybe can segue into the recent efforts towards bringing multi-chain support to the network. I don't think this has been shared already with the different working groups, but we do have Adam and I believe Ariel also on the call. So could we probably talk about a little bit about the recent efforts on the epoch, or this recent work on the Epoch Block Oracle proposal? I believe it also leverages Zach's Data Edge GIP. That one was posted on the forum. I could probably link it here in the chat. But yeah, I don't know, Adam, do you want to speak about this and how we can get multi-chain indexing rewards, essentially? How this will take us there, basically.
For sure, yeah. I feel like I've been talking too much on this so far, but hopefully it's going. You
Oh, you have slides, nice.
Let's keep going. I've got slides and all. Oh, not share, slideshow.
Yep. We see it.
So pretty high level stuff. And yeah, this has been a really fun thing to work on actually with Zach and Ariel. I think it particularly like kicked into another gear when Ariel and I were together in Denver a couple of weeks back. So like broadly, let me move you around. Like the problem is that subgraphs are multi-network. Like we've got users on so many EVM chains and now some non-EVM chains that are building subgraphs. And it's a huge part of our growth over the last year, but the graph network is not yet multi-network either. And we obviously know that that's part of the longer term vision. So like the broad problem, and I have to move this around again, is around allocation closure. The essentially like with Ethereum mainnet subgraphs, there's a really simple rule. You have to close an allocation as index for every at least 28 epochs, and you do that with essentially the first block of a given epoch. So that then ensures that you are actually indexing with a certain amount of recency, and allows other people like your proofs of indexing to be cross-checked across the network. The challenge when you have other chains is that different chains have different block speeds. They have block speeds might be consistent but much faster than Ethereum. They might be inconsistent and variable. So actually lining up what blocks allocation should be closed with across chains is not immediately obvious. And so there are a bunch of options that you could kind of leverage to try and solve this problem. So Oracle, arbitrated cross-checking, a sync chain idea. We talked about the gossip network a lot. State bridging, there are bridges across some of these chains. And then also having actually more sort of graph deployment stuff on the chains that are being indexed, not just the protocol chain, which is Ethereum mainnet. Bunch of considerations here, what's the amount of upfront work? How much does it cost to add a new chain? What are the decentralization implications of what we're doing? Operational costs, indexer costs as well, because it's not just about anything that's being run to enable this. Also legibility and how easy it is to understand what's going on, and then data freshness, which is a slightly separate one, but it's this problem of essentially subgraphs lagging the chain head, and we want to incentivize indexes to be closing allocations with with the most recent data indexed. And one way to do that would be to kind of close allocations with even more recent blocks. So these are a bunch of things that sort of go into the decision process. In terms of the proposal, we're proposing Oracle or Delphi, I think, at least Google Images said it was. Essentially an Oracle approach. This in a way is like a slightly pragmatic decision in terms of time to market, in terms of simplicity, but also in the knowledge that actually there a lot of the research that's being done around L2 might actually change the dynamics or location of the network. So doing anything across chain, which is too tied to specific bridges, might be longer term throwaway work. And yeah, obviously this is a really super high priority thing for the network. So this is what we're kind of going with. In terms of the design, this is actually the currently designed smart contract. So as you can see, it's this is it. I couldn't even tell you how many lines that is without comments. It's I think 4, 5. And so I guess the question is sort of what's going on, and this is I guess alluding to the post which Zach GIP, I think it's 25 in the forum, which is this idea of data edges. So I will not explain it as eloquently as him, but essentially this is the fact that actually storing data and doing processing and calculations on Ethereum is very expensive, but essentially storing call data on Ethereum is relatively much cheaper and gives you the same sort of security guarantees. And so the idea here is that if you can actually just pass the call data to this fallback function, which actually could be called with any selector, then essentially you get that data onto Ethereum, and if only there's a way to then process that data, that's what subgraphs do. Subgraphs can detect those calls. They can process data that's been encoded in a really efficient way. They can then create state and do processing and update stuff. And so essentially you get something that's almost like an L2. And so we're pretty excited about this as a data as a sort of new model doing stuff. This is what got us particularly excited when we were like hanging out in Denver, talking about doing this together. So it's called data edges. Yeah, I guess I said that already. In terms of what this gives us overall, like from an architecture perspective, essentially this smiley dude on the left is the oracle. So the oracle will get any of the sort of prior blocks from the subgraph, and then all other blockchains. They'd essentially then encode the data, pass that data as call data to the data edge, like pass that to that super simple contract on mainnet. You then have a subgraph listening for any calls to that contract, and that's actually where all of the execution logic lives. So actually, like any processing, any changes would actually all just live in subgraph definitions rather than in Ethereum. Then, as an indexer, you'd be indexing a subgraph on another blockchain. You'd then be able to get the epoch block, which was detected by the oracle from this chain, and then you'd be able to close the allocation on mainnet with that block. So super simple. Key question here is obviously there's a big question around like operations. There are a bunch of things which can go wrong in this process, whether it's like forks on these other blockchains and how you like handle them, like how you handle situations where like how you're making decisions around around upgrades or like disputes or like all those kind of things. And so I think this is one thing where in the GOP that's in progress, really tried to call out a lot of the like all of the implications and all of the different situations, because I think this is an area where we do want to beef up and it like improve our robustness, like as a I guess core development community and supporting these core protocol pieces. So in terms of status, the data edge GIP is on the forum. The epoch block Oracle GIP, which is basically a much more detailed rundown of sort of what we've just gone through, is in draft. There's a proof of concept of repo, which is kind of doing this. There's a deployment on Ropsten, and kudos to the people everyone who's kind of swarmed. So Juan, I think, has come in as an expert, so like subgraph author to like start decoding this data. Zach's been doing some incredibly efficient decoding where you're essentially submitting for sort of 25K gas, which is tiny for quite big data. And so we're at the point now where it'd be great to start talking to other people about it, get general feedback. So I'll pause there. Ariel, I don't know if I missed anything that you would that you'd call out.
Not sure if you have Ariel on the call, actually. Now that I don't think we have. And unfortunately, Zach couldn't also attend today. Pretty sure he would be very excited to talk about this. But yeah, we have some minutes before moving on to the next one. So I don't know if Brandon wants to talk about this as well.
Yeah, I guess one thing I would just add is that, you know, this proposal, I think it really shines in its simplicity. So it doesn't require us to make a ton of changes to the existing like allocation management, the POI data structure. It's going to add some, so Adam mentioned some of the operational considerations. It's going to add more work to the arbitrator, because you're effectively, you know, it's not that the smart contract itself is enforcing whether like you can submit a given POI for, you know, this chain for, you know, this epoch. It's that we're expecting indexers to submit the correct, you know, POI given what's in the various charters, you know, for what a valid POI looks like, and then that's something that could be handled out of band in disputes. So I think initially, you know, similar to when we've rolled out other features where like they were new, I think there probably will need to be some forgiveness early on, like maybe where the arbitrator, you know, exercises some discretion. But this is just going to be a new type of thing that indexers need to be concerned about, and a new type of thing that the arbitrator needs to be aware of. So, those I would say are the drawbacks of this approach, is that there's kind of more human, you know, rooms for human error and human subjectivity sort of at the edges. But it's certainly not where we want to end up. I think as Adam alluded to, you know, I think moving to L2 and kind of understanding where the protocol logic will live for, you know, some period of time will allow us to make a longer term investment in like what the multi-blockchain bridging looks like. And there are proposals in the forum as well that we've discussed that are a little bit more, a little bit less subjective, rely on the arbitrator a little bit less, and allow for more recent data freshness guarantees. You know, so because of the nature of this type of bridging with the block oracle, it can't be too granular because of the things like reorgs and so forth that Adam mentioned. So some of these other proposals that, you know, we might evaluate in the future would allow us to, you know, for example, say that this POI on, you know, on Solana needs to be submitted within 5 blocks of the chain head, you know, whereas today I think it would be safer to give a guarantee of like half a day or, you know, a day.
Yeah, I think it sadly like a lot of these cases where there's no perfect fast answer, but yeah, like optimistic that we can do something meaningful, useful, and interesting here, but then also like learn and prepare for the longer term, slightly more robust versions.
Yeah, 100%. And I think a big focus, you know, some of the recent R&D offsites, you know, with the different core dev teams has been working group formation and kind of this emerging like protocol operations, you know, working group. Now that we have like the subgraph oracle, we have, you know, we have the arbitrator role, we have various fishermen. Now we'll also have like this block oracle. And so, you know, I think it's good that the core devs have been focusing in this area, but it's definitely an area where I think across our various teams will want to, you know, make sure we're all making, you know, the right amount of investments and, you know, and keeping these new services that are spinning up, you know, alive. And there's, you know, other GIPs in the forums that are potentially introduce even more, you know, services. So this is something that we'll be living with for a while until we can, you know, I think some of these we'll be able to eliminate, you know, with future proposals.
Okay, thanks, Brandon. Yeah, you mentioned something that we'll be covering during the next core dev call. You've just alluded to the different working groups we've been formalizing at a core R&D level, let's say. So that's something we'll cover in 2 weeks from now. So yeah, people that are listening, please make sure that you tune in. I think it's going to be great. And yeah, let's move on to the last thing we had on the agenda. We have Alexis from Semiotic also sharing something that I believe has not yet been shared with other working groups that much. So it's pretty exciting. It's, I believe, the result of months and months of trialing, of experimenting with how we could build some sort of automated framework for cost modeling, or a better cost modeling and a better user experience we could attach to Agora. So this should be interesting to see how while we're building it and how we're thinking of productizing it. So yeah, Alexis, do you want to take the stage and walk us through what you guys have been built?
Yeah, sure. Hi, everyone. Okay, let me share the desktop, I guess, and do this. That works, right?
It does. We can see your background only. Not sure if that's what you're trying to share. We just
Not at all.
yeah, we just see one folder called graph node. Yeah, we only see your background really.
Okay,
Maybe it's the
that's
second screen.
Okay, I'm gonna retry it.
But
What's going
it's a nice
on?
folder you decided to add. If you had to add one, that was the right one.
Okay, I'm gonna do that because it obviously doesn't work. So we're gonna do it that way.
We can see the browser. Yeah, we can see the slides.
Okay, so anyway, so yeah, the work I'm gonna talk about is cost model automation. So we know that most indexers don't want to write Agora models by hand, and I can understand that because I'm not doing that either. And yeah, in any case, you may have heard about our research on machine learning used to predict the costs of GraphQL queries. So basically a magic neural net that takes GraphQL query and spits out a number. And you know, as we've built tools and we've analyzed the behavior of queries from the hosted service, etc., we thought about a shorter term solution that we call basically a automatic Agora, automated Agora, or automated query pricing, something like that. In any case, so here you can see the gist of it. So this is the spirit of what we're trying to build. And you can see that so in blue here, you have the existing blocks of the indexer stack, and we are adding new logical blocks that will analyze the queries that log the queries that the indexer receives, compute some statistics on it, and compute a cost for the most common queries, or whichever other statistics that an indexer would want to use. And so among those costs, it could be the actual wall clock time of executing a query. It could be rerunning the query through an instrumented Postgres instance that gives more details about the Postgres costs, or running through an instrumented graph node, which will give more details, such as the peak memory used by that query in particular, how many CPU cycles were used for that query, things like that. So here's a rough idea of our current progress, more details about what we're doing right now. So there might be better solutions to capture the queries that are received on the indexer side, but we've decided for now to pretty much capture and filter the standard output of the graph node, and push the GraphQL queries to a RabbitMQ queue, such that we can implement pretty much a relief valve. So if our system is slowed down, is slowing things down, we don't want to slow down the graph node. So we are using RabbitMQ in the middle, the message passing layer, as a relief valve. Also simplifies our stack here. And then we're extracting the information from the GraphQL log line. We normalize the query. So we built a tool to normalize the query in many ways. So you reorder alphabetically, the arguments, etc. Remove arguments that shouldn't exist by analyzing also the schema of the subgraph, etc. Yeah, we store. Right now, we've come up with a schema to store those queries into a database, because we really wanted to separate the query logs from the other logs coming from the graph node, to not pollute any other system that you might use to monitor your indexing operations and look for errors and such. So yeah, that database stores the logs in two tables, and one table stores actually the entry. Actually, that's the next slide. Sorry. So it stores the data in two tables. One is the actual logs, and you get the timestamp, the query execution time from the query node, and the query variables that were extracted from the query. And we store just the query hash. And so that's a method for compressing those logs, because we've observed that those logs can accumulate really fast and become huge. So any compression here is good, I suppose. And then we have another table that stores only the queries. So the correspondence between the query hashes and the queries, and those queries are modified in such a way that all the variables are removed. So you get those variables in the actual logs table, but in the queries table, you're just basically storing the skeleton of the query. So that's really for the compression method. It also makes statistics easier if you're really looking for how frequent a query skeleton is. Yeah. So in any case, the idea on the thing we want to do from by using those statistics and pretty much let's say here you want to compute the cost for one of the most frequent queries for a particular subgraph. And so you would have another another component that will run the measurement on that query, and run the query through a instrumented graph node, instrumented Postgres, etc. Extract a bunch of numbers. So that could be itemized SQL costs, memory cost used by Postgres, memory cost on the graph node, CPU cost on the graph node, the size of the response, which is a good translation of also what your egress will be. And then the indexer can use a cost model that is based on those measured costs for the query, so slightly more intuitive. And then you can imagine also that there is a global cost multiplier that could be adjusted as a function of competition on the subgraph, adjusting your overall, shifting your costs such that you still receive queries at the right price. And your server load also. You could imagine that you increase your costs as your server gets more load, such that you can get less queries, pretty much, and still deliver good service quality. And you can also imagine having a frequency discount, and so as a query is more frequent, you might apply a discount on the price. And at the end of this, so this is in flux, right? This is really what we imagine right now we would compute, right? But if you have any ideas, we're open. In any case, then we would automatically generate an Agora entry with a price, and then we would push that directly to the indexer agent automatically. And so the idea here is that you would have an end-to-end system that the indexer could tweak to some extent, and it would automatically just continuously ingest queries, regularly continuously run the statistics, update the Agora models, push them to indexer agent constantly, all the time. No intervention required. That's pretty much the goal here. So yeah, that's it. Those other slides are like more bonus slides. So since we don't have much time, I think it's a good point to stop here. So do you have any questions, suggestions?
I might have missed it in the but this is all super cool. But I think the one thing which just like it occurred to me is like the other side of the sort of indexing cost of a subgraph. So obviously, like running queries is one thing, but some subgraphs are just much heavier to index than others. I wonder if that's something that you've thought about incorporating, or if I missed that.
No, but that could be added in the formula here, I suppose. One tricky part here, I guess, is that it's a flat cost. Whether you receive queries or you don't, you will pay the same indexing cost. So in terms of the economics, I'm not sure how you apply that cost, but I guess you could just apply just a cost multiplier for the whole subgraph. But then you would need to also have an objective measurement of the difficulty of indexing a subgraph. I haven't looked into that in particular. I would suppose that it could be somewhat easier than measuring the cost of a query, because you could leverage just the number of entities that you have in a subgraph, for example.
Yeah, I was thinking.
So one benefit of indexing rewards is they kind of allow us to abstract away the cost of indexing from the marginal cost of like serving a query, right? So there's like a fixed cost to indexing the subgraph, and you incur that cost whether or not you serve queries. And so the idea is that in most cases, we would expect the indexing subsidy, the indexing reward, to cover the fixed costs of indexing a subgraph. And then you can price your queries sort of just on like the marginal cost of serving each additional query. And that's important because if we relied on a model where instead indexers were amortizing the fixed costs of indexing a subgraph over their queries, the larger indexers that are serving the more queries would be able to amortize over a larger number of queries. And so basically there's like a return to scale there, which acts as like a centralization vector. And so part of what having this indexing reward allows us to do is basically like a small indexer can price their queries, in theory, as competitively as a larger indexer, at least across, this one dimension. And it also simplifies, hopefully, the decision problem that indexers face of like how to price these queries.
I guess the challenge there is that the indexing rewards aren't coupled with the work done, but they're tied to the signal and the indexer's allocation, which so everyone's doing the same work and might be just receiving radically different rewards on the same subgraph.
By work done, do you mean queries served, or do you mean just indexing in general?
Indexing in general, so some indexers might have indexed a subgraph and already be comfortably in the black, whereas some may have only just broken even, if that makes sense.
Kind of, yeah. I mean, so there is sensitivity still to like the duration of, how long you've been indexing. There's like sort of an upfront cost, I guess, to getting caught up to the chain head, maybe is what you're sort of indicating. And like the longer you can like sync on a subgraph, then the more likely you are to recoup those costs. So that's kind of a different dimension, but maybe I'm misunderstanding what you're saying.
Well, I think so if you've got a larger, I may be misinterpreting the dynamics of the, but if you've got a larger allocation, like relatively speaking, and you've both indexed the same range of blocks, one indexer has made money on a subgraph, the other still needs to make their money on the queries.
That's correct. So there is a dynamic where a larger allocation on a subgraph does receive additional indexing rewards. So it's not perfectly even across the board. I guess you could call that a return to scale. We do have mechanisms, this is maybe getting in the weeds, we do have mechanisms that we've been evaluating on the econ working group to try and make smaller indexers more competitive on specific subgraphs and discourage large indexers from like quote unquote taking up the space on a subgraph. That's kind of an area of active research, but it's worth noting that it's the allocation that matters, not the indexer's overall capital. So like you might have a really well capitalized indexer that ends up splitting that capital across many subgraphs, which then, maybe you have a smaller indexer that indexes fewer subgraphs, but they're not necessarily at a huge disadvantage, on a single subgraph.
Cool.
And we're already a bit over time, so maybe we can stop here. Thank you all for joining. I think this was pretty cool. As mentioned before, please do subscribe to our calendar to make sure you don't miss any of these calls. Next one is scheduled for 2 weeks from now. So I'll see you there. Thank you all for joining. Have a good day. Take care.
Thanks, y'all.
Thank you. See ya.
Yep.